So I should probably introduce myself first. My name is Nikhil. I'm the secretary of the physics club here, and I'll be introducing our next speaker, who I had an amazing opportunity to intern with him at the San Jose State University under the Department of the Hybrid and Electric Vehicle Laboratory. He is Professor Fred Barez. He's one of the higher up faculty at San Jose State. He's a wonderful person to be around, and he's got a crazy diverse experience in many engineering fields. He's a professor in the mechanical engineering department. He's the director of the Hybrid Electrical Vehicle Laboratory, as I just mentioned, and as well as the Department of Aviation and Technology, which is another key interest that I have. And so I'm really excited to present Dr. Barez. And Dr. Barez, you can take the floor now.
Nikhil, thank you so much for your introduction. First of all, I would like to thank Raja as well as Sharon for sharing their experiences. And I was very pleased to hear what they both said. And I have some background that I think matches both Raja as well as Sharon. So about myself, I have a Bachelor of Science in Mechanical Engineering from Michigan Tech. I completed the 4-year degree program in 2.5 years because I was anxious to complete my graduate studies, try to move on to my master's. So from Michigan Tech, I moved on to UC Berkeley. I completed my master's degree in 1 year in mechanical engineering. I completed my PhD in 2 years in mechanical engineering at UC Berkeley. I was one of the youngest PhD graduates of the ME department at UC Berkeley. During my time at UC Berkeley, I worked at the Space Sciences Laboratory. And one of my initial projects was to build a camera to take pictures of the backside of the moon. As you probably know, we normally do not see the backside of the moon. Every night we look at the moon. Until recently that, for example, the Chinese landed a spacecraft there, as well as we have had in the recent times various countries with their satellites taking pictures of the back of the moon. So that was an exciting experience that I have. I have worked for over 30 years in the area of education. I have taught at a couple of community colleges, at Mission College, as well as West Valley Community College. And it's been tremendous. At San Jose State University over the past 30 years, I have developed over 40 new classes based on my experiences that I brought from industry. Following my graduation from UC Berkeley in mechanical engineering, I never thought I would end up getting into the field of electronics. And I will review something in the area of physics in a few minutes. But as a mechanical engineer, I always thought I'm going to go back to Michigan and work for one of the auto industries. I did have options, but I loved being in California. I didn't want to go to the cold weather of winters in Michigan. So I decided to make California my home. And I started working in industry. The first company that I worked for was Memorex. It was a company that they made large disk drives for data storage industry. Following that, I went to two small startup companies, and I actually started two. I was the founder and the co-founder of two companies, and we were successful, and we actually went public. Then I joined San Jose State University. At San Jose State University, as Nikhil said, over the past 7 years, I've hosted students during summertime in my labs, except this past year because of COVID-19. I have 4 laboratories that I keep students, undergraduate and graduate students, active, and we do research and we publish papers. The first lab that I developed is called Electronics Packaging and Design. It teaches you how to make semiconductor wafers, how to make IC chips, and how to make electronic systems, and getting into data centers to house several disk drives so that you can upload all of your information in the clouds. The next lab that I developed was a smart home and energy efficiency. It's the application of different type of windows, insulation materials, as well as making the house smart so that you can communicate with various sensors inside the house, from checking temperature, increasing the temperature inside the room in the heater or cooling it down, monitoring your house, opening the door remotely. The third lab that I developed is the hybrid electric vehicle. I realized that the opportunity for mechanical engineers is going to be tremendous by companies such as Tesla, NIO, and the others in this area that is getting into electric cars. So I developed a couple of courses in the area of hybrid electric vehicles. And recently I taught a course as a graduate level. That was my third course in the area of electric cars. It's called Autonomous Vehicles and Connected Automobiles. So these are the courses, labs I've developed. The last lab that I have developed is the space exploration and aviation technology. And I see some connection between what Raja was talking about and myself. So this is a little bit about my background. In terms of mentors, having a mentor is significant. My mentor for my PhD studies, as well as my master's, was Professor Werner Goldsmith. God bless his soul. He passed away a few years back, but he was a tremendous mentor. He assisted me. He helped me to finish my degrees quickly because he gave me directions. I responded. He was pleased, and he said, Fred, you're done. You earn your master's, you earn your PhD. At UC Berkeley, when I worked at a space sciences lab, my mentor was Professor Stephen Boyd. He was the chair of the physics department, and he was very active in design of vehicles for space exploration. So he made a long-lasting impression on me. Another person at UC Berkeley was a good mentor was Professor Miriam in materials engineering. One day he announced that he was looking for a person to hire to grade his solar energy class. It was very new to me. I approached him. I said, I would like to become your TA. So he said, okay. He hired me as a TA. Initially, I was struggling because I did not have much of a background in solar energy. So I had to study, and I would go and ask him, can you help me a little bit more? Can you assist me with some of these solutions that I'm supposed to be solving? And he really guided me, and it was tremendous. So the value of mentors are significant. I'd like to go to some of the things that Sharon talked about. Advising. The fact that she said she finally found a way to be able to graduate, she depended on advisors. Be sure you always seek advising. If an advisor tells you to do this or that, do it. But I'd like to warn you, not all advisors really care for you. Some professors, it's very unfortunate, they just want to come to the office to teach a class, maybe give you some advice, but they really are not into it as much as you would like them to be. So this is something I want to warn you, and I'd like to encourage you to seek advice from your other classmates and other people on campus that who is a good advisor I need to talk to. Be sure to visit your professors each semester. Sharon was talking about making sure you go visit your professors. Anytime you go to visit your professor, just introduce yourself. Tell them, hey, my name is Sharon, and I'm in your class, Dr. Barez. So you make a connection. The reason is because when the professor is going to start grading your exam, he is familiar or she is familiar with the type of question you may ask. So she or he understand where you're coming from. So they would understand the process or procedure you have used in doing your problem. The other thing that she was talking about, Sharon was talking about, was time management, stress management. I also like to add project management. I have an introductory course for students in technology program that I give them the value of all these so-called soft skills. Time management is important. I give them a chart, 24 hours per day. I tell them to complete this on a daily basis. Find out where you need to reassign the activities. If you are spending too much time having fun, not paying attention to your education, and your grades are going down, maybe you want to change that. So I appreciate what Sharon was talking about. Sharon also made a good point. In class, ask the question. There is no question is dumb question. Every question is valid. And as she said, there are people sitting in the room, they say, thank you so much, Sharon, for asking that question. I don't know how to ask. Now, I do a little bit differently in my class. I ask the students if you know the answer, raise your hand. Then I point out to the person, I would say, give me the answer. If the student gives me an answer, I give him prizes. So this way I keep everybody awake, interested, and paying attention. If they don't raise their question, their raise their hands, I normally go and ask questions. I'd like to give you a little more information on physics. Physics is considered as one of the fundamental components of science. Physics helps you understand how things work. I am a mechanical engineer by education. In engineering, the topic of physics is significant. The branches of physics may include mechanics, understanding of forces, gravity, Newton's law, the forces of nature and universe. Electricity and magnetism, which provide insight on electrical components, electric energy generation, magnetism, waves, radio, TV, radar communications. Heat, optics, modern physics, which helps us understand heat generation, heat dissipation, thermal insulation, optics in cameras, telescopes, inspection equipment. In particular, you heard from Dr. Raja on all the telescope studies that he has been involved in. Modern physics, nuclear, atoms consisting of neutrons, protons, and electrons. A study of physics, more than any other field, helps in defining a career path such as engineering, medicine, and law, as well as becoming a teacher or an instructor, just like Sharon. I enjoyed the first physics subject, which was mechanics. And that is how I decided to become a mechanical engineer. So I was interested in to be a mechanical engineer, but I completed my first physics class. And I was interested in cars and building things. I'd like to tell you one of my interesting projects. One of the interesting projects that I worked on was the study of effectiveness of highway barriers. In particular, those yellow drums that they are filled with like old tires and lots of sand at freeway exits. These barriers are expected to save lives. These barriers are expected to absorb the energy of a vehicle at about 60 miles per hour. And in case a driver misses control, the vehicle impacts these drums and ruptures them to save the driver, since the energy of impact damages the barriers more than causing bodily damage to the driver or the vehicle. This was the first time I experienced the application of impact, conservation of energy and momentum, which I studied in physics. One of the things that I do in my classes, some of you guys mentioned being very visual. Roger just made that comment too. I am very interested in bringing props and experiments in the classroom if my class does not have a lab component. So I do experiments, I do demonstration, and my students tell me, Dr. Barez, thank you. We are very visual. We see the concept when you demonstrate. When I completed my studies at UC Berkeley, I wanted to get a job, and there weren't that many companies working in the area of vehicles in Silicon Valley. So I became interested in electronics. I worked in design and development of hard disk drives. These are the ones that you see in your PCs at home. These disk drives store mega and terabytes of information. In order to store electrical and magnetic data on magnetic disk platters, a small magnetic head flies over such disks. Comparison of such flying is like having a jumbo jet flying at 500 miles per hour at a distance of 1/4 of an inch above the surface. You can just look at the magnitude of what's happening. The surprising fact for me when it comes to physics was we were told that these products, they're not going to be able to sustain flying below 20 micron. As you probably know, 1 micron is 1 millionth of a meter. But lo and behold, and to my surprise, we have such products flying at 1 micron, which is below 20 micron. This is due to the fact that the air molecules can deform. They are not solid materials. They are very flexible, and they can squeeze underneath the 1 micron spacing. When I took physics 2, electricity and magnetism, I was not discouraged in physics. Rather, I was a little bit difficult for me because the concept was more of a concept and conceptual. It was not so visual. I could not see the currents passing by. Yes, I could see the signals on the scope, but it was not the same. But in spite of that fact, today I'm working on electric vehicles. The misunderstanding that the people have in physics is the fact that they say it's hard. In my opinion, all subjects have their own difficulty, and we need to develop a passion and get to practice it to enjoy more and more to benefit the society and the mankind and making this a better world. This is what Roger also said, develop a passion. So this is what I'd like to remind you. Furthermore, towards closing, I'd like to tell you, develop a passion. Physics is wonderful. All fields of engineering depend on physics. If you're strong in physics, you can break any barriers and you can do well in your career. Thank you so much for listening to me.